Can you hear me?
Wake the farm up. Let's kick it good. Yeah, wake the farm up. Welcome you all to a fascinating show here. I'm excited. There's a lot of wiggle room to see where we go through this one, see which way we go. We're going to be going subterranean. We're going to be going future-specting. We're going to be going all kinds of places I can only imagine. I don't even need to imagine. Let's just do it. Here we go. Ladies and gentlemen and everyone, let's welcome in. This is Sam Baker. Sam Baker of WriggleBrew. What's up? Say hey.
Hey, thanks for having me here. I'm ready to wake the farm up. Let's do it.
All right. So yeah, Sam, tell us a bit. So I'll introduce it a little bit, So WriggleBrew is a company that you and your friends have started. I love that part. You're an upcoming entrepreneur, figuring out things and ways to help heal the earth and, applying that into your school and technologies that you guys have grown through that and what's come out of your researches and educations of, your minds and, working with the technologies that are. I'm super fascinated by how you guys are working out how to digest styrofoams and turn them into an organic compost that can be used, by nurseries and gardeners and all kinds of people, farmers, wake the farm up. What's up,
Thank you, man. Yeah, we're doing a lot of really interesting stuff, and it all comes back to worms, earthworms, and those wonderful decomposer organisms. They're underneath our feet all the time, and I think they should be in our hearts and in our minds all the time because they are stupendously capacious little organisms. They do so much for us and we never recognize it. We think about bees all the time. We think about butterflies. These are organisms that give us pollination, that provide beauty to our life. But earthworms and other worms and decomposers like them, they play just as important a role. Maybe they're not as cute, but they have some abilities that we've been able to tap into, myself and my friends, and we're trying to commercialize them, bring them into the market, and we've had some really good results.
Oh, wow. Yeah. So working with the worms in, that kind of way and turning it into a business. And so you guys are located down in Florida. Is that right?
Yes. We're out of Central Florida. We're in Orlando. So kind of an unusual spot for agriculture, but some serious benefits to where we ended up being.
That's pretty cool. What kind of benefits are those?
Well, it turns out that right outside of our university where we studied, there is a guy named Teddy who's been farming earthworms for 30-something years. By sheer coincidence, he happened to be just right outside of our university. And so we were able to find him, make contact with him, and learn from him a lot of the secrets that he had accumulated over a lifetime of working with these worms. And he passed on a lot of knowledge to us, and he also provided us with a lot of earthworm castings.
That's awesome.
That we were able to do a lot of our early research on.
That's awesome. And so that's the heirloom of the worms that you're working with.
In a way, yeah.
What kind of worms are they?
So primarily we're working with a species called Perionyx excavatus, which is a blue Indian earthworm. That's what they call them, blue Indian. They're not really blue and they're not from India, but they are a really, really good earthworm. They're very heat tolerant. They jump around a lot. They're very active.
They jump?
They do. They jump a lot. They're not. So there's actually two kinds of worms that jump a lot. There's one that's actually called a jumping worm, and then the blue Indian as well. And they when you disturb them, they will jump up as a defense mechanism. It's really interesting to watch.
That's pretty fascinating.
But they're kind of funny.
They're really doing the breakdance thing.
Yeah, they really do. They do the worm.
They set the vibe for that.
But what's cool about them is that they are extremely well suited to dealing with high amounts of salinity, high amounts of heavy metals. In fact, they're one of the only organisms that can actually sequester and isolate heavy metals out of soil.
How do they sequester it out of the soil?
That's a very good question. So the way they do it is when they move through the soil and they eat material that has heavy metal in it, their body separates the heavy metal ions from the material and it gets baked into their biomass. So when they excrete the material, it doesn't come out in their feces. And they do this generation after generation. So even as worms die, the next worm absorbs the heavy metal content of the previous generation in order to prevent these metal ions from being absorbed by plants around them. And they do this because it makes it so that their young, who are continually in a growing population, will have less and less exposure to that heavy metal than the prior generations did.
Wow, that's a pretty cool strategy in ecosystem giving, thinking outside themselves to kind of like pure love from a species there. Wow.
It's a wild symbiotic strategy, but it really, really works because, and they actually do this with a couple different things, but it really works because it means that their offspring, their children in essence, will be more likely to succeed than their prior generation was, than they themselves are. And that's something I think we could potentially learn from ourselves. There's a lesson in even the most humble organisms.
I love that. Yeah. So if a bird came and ate one of these worms, would it be ingesting a large amount of heavy metals? Like if you actually ate these worms themselves,
not
accumulate
really.
It, like
it gets spread out through the population. Now these worms also live quite deep, so they don't really spend much time on the surface at all.
Okay.
So there's very little interaction that they have with birds. In fact, people think about earthworms as kind of a mono species, but there are really 4,000 species of earthworms. Some of them live much deeper than others. Some of them have burrows. Some of them live in almost kind of colonial clumps. So they have many different strategies and tactics they use. And these guys are different from the kind that you might see on your sidewalk or on your yard.
Right. But they look similar?
Oh yeah.
Okay.
I mean, for the layman, Teddy, he was wonderful because he could point at any worm and just tell you immediately what it was. He'd count the bands, he'd look at the colors, and it was amazing.
Know all the identifying characteristics and
the size of it, the shape of it, the subtle off color. He'd tell you exactly, oh, that's a Syaena fetida. Oh, that's Periodus excavatus. Oh, that's actually a North African nightcrawler. He just names them like that.
Like from all over the world.
Yes.
Yeah. Do these worms live in Florida, like in the native soil now?
They do. So in Florida, we have almost no native earthworms. In fact, North America in general has almost no native earthworms. And so most of the ones we have are really invasive when you think about it. But we also end up with this weird diversity of species from all over.
Absolutely. Yeah. We live in new forests that never existed, and we have layers of bedrock, and we have layers of plastic too.
Yes.
Which is, a fascinating, so this worm we're talking about right now. I'll have to listen to this episode a few times to be able to remember and off the top of my head, its genus and species name for sure.
Sure.
But it's is this the same worm that's helping digest styrofoams and plastics?
So a little bit. So all earthworms actually have, well, for the most part, all the earthworms we commonly encounter actually have this bacterial culture in them that is capable of digesting some plastics. And in fact, there's a couple bacteria that actually do this digestion work for them. So the worms themselves, they're always relying on bacteria to kind of do a lot of the digestive heavy lifting for them. The only worms we see that really eat any considerable amount of plastic in nature are larval worms. So mealworms, waxworms, black soldier fly larvae, superworms. Those guys will actually eat polystyrene and styrofoam plastic when they come across it in an environment. Literally, they chew on it and they're swallowing it and they're actually digesting it. But they only do that really when they have no other choice.
Oh yeah,
but,
much
they don't.
tastier
It's just
things on Earth, right? Yeah.
You wouldn't want to eat leather, if there's meat around,
Yeah, right. Or a ball of hair.
Yeah, exactly. But you technically can. Right. And it's the same thing with these worms. So when they come across plastics, sometimes they eat them, but what's actually in their gut that's allowing them to eat these plastics are a really hardy group of bacteria that have enzymes that can actually do things like break polystyrene down, break down benzoic acid, break down a lot of the byproducts of plastics. So if you take something like a plastic water bottle and you heat this up really hot, it will break down into a material like benzoic acid. It's basically an organic kind of liquid, like a soup almost. And that is something that our bacteria can actually eat. So we, instead of actually using living worms, we build what are called bioreactors. They're kind of like a composter.
Okay.
But it's, instead of being a solid composter, it's a liquid. So it's like a big glass jar with liquid inside of it. We put our bacteria in there. We give it the same conditions you'd find in the worm's gut, and then we feed our plastic into it.
Wow, you made a giant worm's gut.
Exactly. It's just a giant worm gut. And it's so cool because it produces the same kind of output you'd find in a worm's gut. So if you take this bioreactor and you feed the plastic into it, it breaks down over a period of about 5 days. And what comes out is basically what you'd find halfway through the digestive process of any given worm. And we can take those materials and we can turn that into a kind of jello and feed that jello to earthworms, and they'll complete the digestive process in about 2 weeks and poop out earthworm castings.
Wow. And you guys have like tested these castings. There's not like plastics or like poly stuff that's like residues or anything like that.
As far as we've been able to verify with our tests, there's nothing there yet. Now, we still want to put this through a very rigorous set of tests because we're trying to be more responsible than the people who kind of started all this stuff. So we're going to have some third-party folks take a look at it and verify before we really start producing any quantity of worm castings this way. But right now, everything's looking good. It's passed every chemical test we've been able to put it through. We've even grown plants with these worm castings, and they grow exactly the same as normal worm castings. And according to Gabe, they taste the same.
It's like the giant worms of Dune or something, you know, like it's like how they made the spice or something, you know.
That would be kick-ass. And I honestly, when I was first thinking about like names for the company, I was trying to think of some way to like reference Dune because I love the Dune books, but I just couldn't think of it. And one of my friends came up with the name WriggleBrew, and it was so funny. We couldn't not name the company that, you know?
Yeah. You know, when, you know, I first heard the name, you know, my brain first like went into like a microbrew kind of situation or something, you know, because there's a lot of those.
And it's not far off.
And you know, it's like you guys are actually like brewing things. It's almost like a portal though. Like, you know, as you describe this process, it's like this portal. And I did get this image of like a giant worm, like from Dune or something, you know, but we're just like feeding plastic through it, and it's like digestion's just like yum yum yummy yummy more. I want more yum yum yum, and it's just like spitting out beautiful earth, you know. Like it's like, yeah, that's amazing. I'm like so mind blown by this concept and process. I'm so stoked to, you know, hear about this and keeping connected and maintain ground with you, Sam Baker. Like, shoot, you know, like I think everybody's getting excited here. I think we might need like let them like give us a round of applause or something again. Oh, they're laughing at me now. Shoot.
I mean, you gotta laugh at yourself sometimes.
Yeah, I'm excited. You know, like plastic's an interesting thing, and you know, it even adds a layer to this like sci-fi kind of aspect. I'm working on this like thing where like we realized that microplastics were in everything. You know, I've, you know, shared these, you know, things on this podcast where, you know, like in this world though, you know, it's 1,000 years later and we've developed like body organs in our body that help us process the microplastic, and we've adapted and like grown over time to do that. And to me, it's interesting, you know, like you found like a current, actual contemporary way in which biology is digesting it and turning it into organic substrate of Earth, you know? And
exactly.
Yeah, I mean, who knows? Maybe our bodies will do that if we don't create more of these portals to put the plastic through. So,
one of the things on that topic that I think is really interesting is the fact that the microbes are doing this with an enzyme, right? Like, they're producing compounds that are actually breaking the plastics apart. So if we could harvest those enzymes from them, we could start bringing those to like landfills. We could start bringing them to ocean patches where the plastic is. We could even potentially use those in medicines to break down the plastic in situ.
the spoon of plastic they say is inside of our brains now.
Exactly.
Break that down and move it out.
I mean, I'm not a medical person. My background is chemistry, not biology.
Sure,
so I couldn't speak too much to the feasibility of that. But from an outside perspective, that seems like something reasonable that could be done. You know, I'd want to work with some people who have a medical background to figure out if that's possible. But I mean, it opens a lot of different possibilities.
Yeah, it's so fascinating. And that's like a whole nother portal to it, you know, to this conversation, really. Like, yeah, it's even looking at your site, I do feel like there's you guys have gotten awards. You know, how's that felt like getting awards, you know, and you have, like, I've seen some of the videos, like, you've been doing this stuff with friends of yours that, you know, you've been friends with since high school, and you guys have been talking about these things together. I can just imagine, like, on the back of a truck out in the country, some side, you know, and, like, just having those, like, conversations of life. And, wow, you guys are really doing something here. How does that feel? How does that feel to be, like, getting awards and, you know, getting, like, do you feel like you're getting to share what you're trying to bring to the table and, you know, it's, like, growing on you?
Yeah, I mean, it's a hard thing to describe because it's really gratifying, but also really frustrating in some ways, because I feel extremely blessed and fortunate that I'm able to actually be part of this and help make this research be a thing. A lot of this research, I should know, is Gabe's work. It's not my work. It's not Ilo's work alone. It's Gabe's work. It's all of us who've worked on this together. But Gabe has been a really big key piece in making this happen.
Yeah, I saw. You can see that in the videos, folks. I'll include some links in the show footnotes too, so you guys can explore what's going on here a little bit more and wiggle into it.
He's a really shy guy, so he's not he's not always on camera, but he's a lot of the brains behind making this happen. I feel very fortunate I'm able to be a part of it. But at the same time, there's a frustration because I know we could do more with this. Like, I know we could do so much more to get rid of plastics, to improve fertilizer. But it's been really challenging because we are all still very young and very inexperienced. I'm 24, Gabe's 25, like, all the guys are around the same age. And so we don't have a lot of the know-how to really launch this into something that can scale. You know, I feel like we're going slower than we could if we just had, like, the right funding behind us, the right experience behind us. Because every day there's more plastic. Every day there's more crap in the oceans. We could be a part of making that go away. We have the technology. We just need to put the pieces together. And it's a really hard challenge to do that.
Yeah, I feel you for sure. And that, I hear your challenge, and I feel the, you know, call to help and support. And, you know, I'm definitely, you know, sending some elves on that for sure. There's, you know, they say elves have sharp ears, and it's for a reason. Hope some, you know, ears perk up and tune into this frequency, you know, like I did. You know, as soon as you had connected with me, I, like, you know, just kind of dibbled into, like, some of what you guys were doing. I was just like, yeah, what's up, Sam?
I really appreciate it.
Yeah, this is so Wake the Farm Up. This, like, you know, just so yeah. Tell us a little bit about the fertilizer aspect. So, like, you guys have several different products, and, you know, I see people can, you know, order tanks of it. You know, so
yeah.
I mean, like, I have so many questions. Like, do the people get the tanks refilled? You know, different things. Like, you know, like what kind of fertilizers? You know, tell us about some of the different things.
Well, let me dig into it. Yeah, let's go down the wormhole. So
yeah,
we originally thought of this company as a fertilizer thing. We didn't know about the plastic process until actually a few years into this. So our first goal was to prevent fertilizer runoff. Because where I live in Florida, we have a lot of fertilizer use, and a lot of it causes what's called red tide. So red tide, if you weren't aware, is where K. brevis algae bloom in these massive toxic blooms when a huge amount of nitrogen or primarily phosphorus runs off into a big open area of water. And here in Florida, that kills a lot of our fish. And it killed all the fish in my favorite fishing spot back in 2019 when I was a freshman at UCF. And I was really upset about this because that was a spot I used to go to with my grandpa It was a spot that he went to probably with his grandpa. Like, I don't know how far back that chain goes, maybe 6 or 7 generations. But when that happened, I felt really upset. And so I went to Gabe about it and I asked him, what could we do? And he explained to me how earthworms make amazing fertilizer that doesn't cause runoff. And that's because earthworm fertilizer really is just soil. It's humus, it's humic acid, it's fulvic acid. And he also showed me guys farming worms on the internet he found who were doing this, basically feeding the worms kind of manure, farm waste, food waste, like garbage almost, leftover material. So it makes you think, like, if we can make fertilizer from these leftover materials, and the fertilizer you get out of that is really potent and it's really good for the environment, why aren't we doing that? And it was kind of a call to action. So we decided we're going to figure out a way to make a worm tea that we can actually produce in bulk. Because we ended up finding out that the worm teas that most people make, in your backyard or whatever, they go bad really quick. They have a shelf life of 24 or 48 hours.
Absolutely.
So we were like, we got to find a way to make this shelf stable. And that's what WriggleBrew became.
That was that was the initial like trajectory and dive into this, and you've gone down now, like we're going into the wormhole even further. So then what happened?
So we made some, we won a couple competitions and got a little bit of funding because we were poor college kids. So like we didn't want to take out any loans. That was scary. And we didn't have any other money. So we won these competitions and that allowed us to make some samples, which we sent to some farms and they loved it. They had really good results, specifically people growing soy and corn and a couple other row crops. They just loved it. And so we ended up getting bigger and bigger orders and we ended up selling at retail and a few other things. And along the way, Gabe's research yielded this whole plastic digestion direction.
So
because
cool.
Some other people, they had been working on using worms to eat styrofoam. And again, it raises that question, like if they can eat styrofoam and it doesn't kill them and we have plenty of styrofoam, why aren't we doing that? And again, it turns out there's some problems. But again, it's like, okay, those are problems, but maybe they're solvable challenges more than they are really problems.
Yeah, I'm imagining some of the problems could be something like it's hard to collect the styrofoam in the right state where it doesn't have like weird particles or other chunks of plastic that they don't digest in it. Is there like certain plastics, like so it's more of a specific kind of plastic and there's other kinds they don't digest or they can't chomp into it because it's not soft enough? Or
Exactly, yeah. So you're right on the money. Like if it's not soft enough, they can't chew it. And that actually really was the whole problem, is that the worms themselves don't want to eat plastic. They only eat it as a last resort and when you really force them to, and they'll only eat some kinds of plastic. But what's allowing them to do that is the microbes. So if you can take the microbe out of the worm and build a big worm gut, a gut that doesn't have to chew, a gut that doesn't have any energy requirements of its own, a gut that, it can actually survive, in the long run, and take the plastic and put it in that big worm gut, and it turns out that's a bioreactor, you can get the digestion of not just the soft plastics, but the hard plastics too, and you can get it to happen a lot more clean and a lot faster.
Nice.
And it took us a while to figure that out.
So like you had all kinds of trials and errors. I remember seeing on the website you guys had mentioned that you have, grown a lot of plants, but you've killed a bunch of them too. I totally get that, like planting so many plants over the years and, sometimes you feel like you're killing something because you put it somewhere and it just doesn't make it. But when you put 1,000 trees in somewhere, it's hard to simply go and nurture every one. But if you didn't put those 1,000 in, like that 700 that really kicked butt and made it, are growing great. You wouldn't have put them in if you wouldn't have tried,
And that's the thing about science. Like if you don't try, you're not going to know what works. And for us, when you work with worms, that can be really heartbreaking. When you have some worms that you really want to succeed and you really want them to live and they eat what you're trying to feed them and they don't make it. It's horrible. It's a horrible feeling. But that's part of the reason we're trying to work more with microbes as well. And why we've been working more with the microbes is because the microbes, they're a little bit out of sight, out of mind, but they reproduce so quickly and they deal with such hardship. It's a lot. I think it's a lot more ethical to work with them as well.
I mean, microbes help work with, like my own personal traumas, just like they say, putting your hands in the soil, and like, going into depth with that. Yeah, it's like this interchange of microbials living and dying. And there's constantly little flakes of my own skin coming off, all the kinds of things interchanging and exchanging. And it's, yeah, it would be very overwhelming. I mean, right now we're slightly overwhelmed by knowing the news around the whole entire world about the humans. Imagine if we knew the news about all the microbials all the time. Shoo.
I mean, it would be too much for any one of us, I think.
Yeah, I'd probably turn into a worm and wiggle down deep in the earth somewhere.
Something to think about on that aspect, actually, is, I was talking about earlier how we care more about bees than we do about worms, but we really do need worms because worms produce the calories of the nutrients that become our food, right? And when you look at like a farm or a pasture or where we're growing animals, for every pound of cow you have living above ground, you need an equivalent pound of worm below ground to support that, just to build up the grass and the soil to actually feed that cow. Which means our farmers and our herders, they have two herds, and they don't even think about that second herd. They think about the herd above ground that's making the money, but there's another herd, an equivalent. If you got 60 tons of cattle above ground, you will have 60 tons of worms below ground to feed that cattle. And that worm herd is another one that you are a shepherd of, and we don't think about that a lot.
I remember in these old VHS permaculture videos where Bill Mollison, the founder of permaculture, is in Australia, and he's walking with a cattle farmer. And just every once in a while, the cattle farmer would take a chunk of sod, flip it upside down. And I remember Bill Mollison, kind of asking him, like, what are you doing here? And the guy described that if he did that, like on every acre, one little clump of grass flipped over like that, he's seen how it generates like whole generations of worms under that little flip sod spot. It creates like this incubator, and then they just go out, and it makes his fields of grass grow better.
It does.
And digest the cow manure as they come through and all these things.
It's absolutely critical because when you don't have worms, when you don't have mycorrhiza, when you don't have these organisms, the material just sits there. The calories don't get circled around. They don't get replenished. You take marbles out of the bag and never put them back, and eventually there's nothing left.
Yeah, you just take. So,
but if you have the worms there, they give back.
So in some of in your worm castings, like the things that you guys offer, they're not actually worms, but they help generate the sensation in the ground that worms were there, and that it might even generate the opportunity for worms to be invited to start living in that environment. Is that
precisely? So
that's from my own observations. Like some of my listeners might be like, what are you talking about, Elf?
No, you kind of nailed it though. I mean, that's the thing. So it's kind of a chicken and egg problem, right? Like you can put worms in soil, but if the soil is really bad, they're not going to survive. And if your soil is really bad, it probably doesn't have worms. So there's kind of a catch-22 there. So it's hard to bring worms back to a place that's inhospitable to them because they've been gone so long. They died off for a reason.
Right.
So one of the ways you can bring them back is you can introduce better biology back to the soil, bring microbial life back, which is what WriggleBrew does, bring some of the humic content back, bring a little carbon content back, make that soil a little bit more alive. And WriggleBrew also provides nutrition in a very large way. So the plants that grow off of that, they start to drop leaf litter, they start to drop shake, they start to drop other material, and that can bring carbon back to the soil.
Yeah, as they grow. So yeah, that's interestingly, in your guys' testing of it and whatnot as a fertilizer, have you seen results over time? So there's that, you can use it in your annual garden, but for a perennial bush or something, you've seen beneficial results and things like that as a fertilizer. Oh, yeah, I love that. And
we've seen some results that are really unparalleled. Results that people would not see with any other kind of fertilizer.
Cool. And then you guys, expanded here too. Another aspect, is this micronized crab and lobster shell concept, so like understanding you guys are like you're Florida men.
Yep.
There you go. So yeah, like lobster, like these products were like a waste product that you were seeing in the area.
Yes.
Yeah. Tell us about this.
So it all comes from Tampa Bay because there's a huge amount of like crabbing and lobster and stuff they do down there. And all that like shell material, it gets thrown out, a lot of it. So we take a lot of that. And what we do with that is we use that as a source of chitin. So, we're talking about how when you don't have worms present in your soil, it's really bad. Well, it's the same thing with fungi, right? If you don't have fungi present in your soil, then it really affects the immune health of plants. One of the things that fungi do, aside from just acting as like a liaison to plants' root systems, is they also provide this chitin material. And chitin, it boosts plants' immune system. They produce an enzyme called chitinase that reacts to it, and that triggers the production of plant defensive hormones and other compounds. So they need to be exposed to a little bit of it, at least from essentially early childhood on, almost kind of like a natural inoculant. They get a natural immunity. So we add a little bit of that into our brew alongside mycorrhizal spores, so that one, it provides a population of mycorrhiza to start breeding and living in the soil, but two, for the seedlings that you apply it on, it gives them that chitin as if you already had fungi there.
That's so cool.
It's really, really neat. I mean, it's amazing how all these things interlock, but especially with chitin, when plants contact it, you can actually tell because they release a small amount of methyl jasmonate, a gaseous compound, to communicate to each other.
Okay, so what do you feel that compound is communicating to each other?
So it's primarily a communication that tells other plants to kind of be alert, to kind of be on your guard. Methyl jasmonate is usually associated with higher defense in plants, especially of like biting insects, phloem feeders, and things like that. So when plants get a little bit of chitin, it puts them a little bit on a alert status. And for most plants, especially the ones that are grown in like completely solarized or dead soil, plants that are grown in house pots, they do not ever get access to the chitin that they need to put them on that state of alert. And so they almost live their life in a sheltered kind of way, and they're much more vulnerable to disease because of that.
Yeah, it's like they're out in the middle of, some other plants that aren't even communicating to each other. They're, that's a fascinating, I'm totally into biological intelligence and ways in which plants communicate between different species with each other, all these things, I talk about it so often, trying to put the human into the ecosystem too. It's like when you put your hand on the soil, you take your shoes off, people talk about getting grounded and how it feels good and stuff. But it's because they're like really connecting into that big guy and body and, being part of this biological exchange, and you're receiving information, and it's not words or symbols. So it's hard sometimes to describe it and turn it into words and symbols to like be able to share and articulate it in words and, understanding chemical, concepts. That's why I was really curious about that. Right. It's like, okay, so we know the chemical, we know it's communicating something because it's setting their defense tones, so then they're not being naive. And when this certain bug comes through, they already got like their little defense juice ready to go to squirt into themselves. And we can trace that to like higher rates of survival, right? When plants do produce methyl jasmonate, they're much more likely, like 30-40% more times likely to actually survive an attack from like aphids or mealybugs or spider mites. So there's this effect. And we know that they're communicating because we can see the chemical relationship, but it's impossible for you or I to really know what that's like. Right. But we do know that when we add chitin, it kickstarts that process. That's pretty awesome. I think it is. I think it's really cool. And it's something that I fear, it's a resource I fear we're losing a lot right now without thinking about, because as we put more development up, as we put more lawns up, we kill a lot of these actors in the soil. We shut down the communication. We render all these systems obsolete. We make them, so it becomes like a lunar regolith, like the surface of the moon. There's nothing happening. There's no life. There's no communication. And so our plants become very sensitive. They become very easily killed off. And then we try to correct for that by using all these synthetic solutions. And
it just perpetuates this negative feedback loop.
Absolutely. Yeah, I've seen that pattern over time. Yeah, I could think of 158 different cases right now. Whoa. But yeah, we don't need to go into each case. But
no,
it's so true. It's the solutions, you know, like, and it's amazing how every time the more natural and passive, I don't know, it's like, I like bringing this Bill Mollison permaculture guy, you know, I brought him up earlier, so I might as well throw out one of his quotes. I think it's a brilliant one. It's that, you know, though the problems of the world grow ever complex, the solutions remain simple.
Yes.
And so amazing.
And sometimes we as humans look for more complex solutions than we need to.
Yeah, we like to think, you know, it's, you know, we like to overanalyze, and, you know, I'm a botanist, and, you know, I like to know all the names and, you know, species and ecosystem types, and, you know, but sometimes I just go and take my glasses off and it all turns into a Claude Monet and it's all one, you know, so I can kind of like balance and go back and forth. You know, I like to put myself into that, you know, awareness that you know, I'm recognizing plants. Sometimes I don't remember their name, but in that moment, it's okay. I'm connecting with it and observing, you know, how it is in that moment. You know, sometimes just even breaking sticks by the campfire, you get to observe the different tree species and how they splinter and break. And there's information that we get to receive from that, you know, who knows what we'll do with it in our life, but it's there and it's a connection and it's real.
How it smells, how it feels in your hand. The feeling you get when you put it in the fire, does it feel good? Does it feel bad? I mean, I was a Boy Scout. I spent a lot of time outdoors, and those are some of my favorite moments when you're sitting by a fire and you're at peace. You're not required to do anything.
Yeah, you can make a toothpick out of a stick. You know, just carve it and carve it and carve it.
It's when you get to one of my favorite things is when the fire burns down. You're looking at the embers and you're looking at the stars. And you have this wonderful, like, symmetry, mirror vision between the two of them.
I love that vision.
I always remember that moment, that being one of my favorite things when I would be camping, you know?
Yeah, I love that vision. I'm picturing it, you know? I think... Yeah,
there's more symmetry in the ground, too. You know, when you talk about that farmer who's digging his hands into the field, pulling up the worms, you know? They are as numerous. There are as many worms in the ground as there are stars in our galaxy.
Wow.
Each one of them is just as unique. They have that much volume and quantity to them. I mean, think about how big and large a star is, but also how utterly singular they are. Worms are the same way. So are we, so are all the organisms on this planet. And there's so much we can learn, both from looking up, but also from looking down.
I love that, the above and the below, and so yeah, I really appreciate you sharing this stuff with us. I have so, you know, I'm thinking of like more questions. I feel like, is there, you know, we've covered a lot of the different topics, you know, but there's you know, just I have questions. I guess I keep wanting to go. I'm so curious about this like plastic digester, like how
right?
like how long does it, like one vat or whatever of the liquid substrate that you're putting it through last, you know, and is there ever is there a lifespan on that, or how does that, does it perpetuate itself? It perpetuates. Cool.
Yeah, exactly. It perpetuates itself because we are breeding microbes to do this. So the microbes, you know, each generation they breed, they also get a little better at it, you know, the more we do this. So it's kind of like, you know, if you were talking about like, what do you call it? Like a heritage or an heirloom, like breed of worms. It's the same thing with microbes.
I love that.
You can have kind of, because people actually do have that with like sourdough starters. They have heirloom sourdough species. You know, it's going to be kind of the same thing for us. So we're having them eat this plastic and break it down. It takes them about 5 days in a bioreactor, maybe this big, you know, which is maybe about 5 liters, so roughly a gallon of this. They'll eat about a pound of plastic waste in 5 days in something that big.
Wow.
Which is really cool.
So, like, what's the biggest, like, worm portal that you guys have created so far?
I think I mean, I really do think it's the plastic digestion. I think that has so many possibilities. I think it has so many applications. I mean, I was talking earlier, like if we can harvest the enzymes from that, we can go to the ocean cleanup folks who have, big nets scraping the sea and start breaking down the ocean plastics. We could go to landfills. We could start breaking down the plastic that's been piling up there. We could even have applications in human health, getting microplastics out of people's bodies. But we could also go to the places where plastic products are being manufactured, where they're making it brand new, and intercept the waste before it even reaches a landfill, before it even leaves the facility, have it broken down on site.
Yeah. I like, I'm like in the vision room with you on this now. Like, yeah, they could have like water filters coming out of everybody's home that just break down microplastics before they even leave the home, like there's water filters in streams that are like breaking it down, all these little things. And like, then there's a certain point, like then all of a sudden we start getting clean, like that would be so amazing.
Start turning the clock back on all this plastic pollution. Like, I mean, not only talking about like reducing the amount that we're putting out there in the world, but I mean, actually like getting rid of the stuff that's already there. And this is the beauty and the power, I think, of enzyme chemistry, of these enzymatic compounds, because it's not just limited to plastics like this. It could be limited. It could be expanded to all kinds of other toxic waste, other kinds of materials, so the potential of these organisms, I think, goes beyond just the plastic side. I mean, we're talking about how these worms are able to isolate heavy metals. I think that could be really, really huge for dealing with a lot of that pollution, which is especially big in Europe and parts of Africa. So the vision is, it's far larger than me. It's far larger than us. It's far larger than WriggleBrew. I think this is kind of a portal into something that could be transformative for the next 50 years.
I love that. And again, I appreciate you talking with me. Definitely want to give another shout out from the elf to Gabe too for, putting his energy. He's probably working on something right now, huh?
He is, yeah. He's
looking at something tiny.
Thermophiles.
He's doing what?
He's breeding thermophiles. They're high temperature microbes.
What, like just for fun, or like what are high temperature microbes used for, or not used? Like how are they integrating in this adventure?
High temperature composting. If you got high temperature resistant microbes, you can run things at a higher temperature, which means more can happen faster. So composting, but also faster digesters, all kinds of things like that.
Yeah, cool. So like it heats it up a little hotter than like a normal compost situation would be?
Yeah, so instead of running a composter at like room temperature, you intentionally heat it up a little hotter. That way the chemical reactions happen much more quickly. And the microbes that can survive at those temperatures are also eating and moving and doing everything a lot faster.
Okay. That's cool. Like, so I've seen people make hot water heaters with compost, and I'm intrigued by, having compost that's even hotter. And I guess if it's going faster, like, you'd probably need some rotation of some sort, I guess, to be able to switch it so it's always going through something that's heating up.
Exactly. Yep. We have a big machine out here that has a huge metal auger, and it spins almost like a giant screw. And we put the thermophiles in there, and they eat through material. And they'll compost through fresh corn cobs in 24 hours.
Wow. So yeah,
really, really fast.
Tell us about like where you guys are getting materials from. You've told us about the crab shells and whatnot. How are you collect? I mean, you can, of course, if there's industry like secrets that you don't want to reveal or whatever, like I don't need to know the microbes names or something. Maybe there's something you're working on. Just respect. But how do you collect like all the styrofoam and whatnot?
So we're working with our local county. They provide us with a lot of plastic waste. We work with a couple farms. We work with a couple nurseries nearby who provide us with some stuff. So that's how we're able to source a lot of this stuff. And in terms of people we're working with to try and develop the technology, we're actually working with a nonprofit here called 4 Roots. And 4 Roots is really cool because they support a lot of different people. They support food banks and all kinds of other organizations. And they're really big on trying to help soil health and trying to help people health. And so when I told them about what we were doing, they they absolutely loved it, and they've been supporting us really strong ever since. In fact, this space that we're in right now, this is in their warehouse.
Okay.
And we rent a small portion of it from them, which is where we do everything.
That's really great. And so
it's a wonderful relationship.
So, like, what kind of percentage of the plastic in your area do you feel like you guys are getting the opportunity to digest? It's like pretty...
Right now, only a small amount.
But you're generating a fairly large amount of product from that. So that's pretty amazing. Oh, yeah, I'm intrigued.
So most of our product right now is just made from regular worm castings we get from actual worm farmers. So we're not turning the plastic into product we sell to people yet. We're mostly just sending that to farms for free for testing.
Clarified.
Yes. But we have been able to destroy 400 pounds of plastic so far.
That's awesome.
And
so this is really fresh. Awesome. This is really fresh, huh?
Yes.
Yeah.
And I really think this is the thing I'm talking about, why I was a little frustrated. Like, I think if we can get some funding, we can get some like help, we can really expand that. I mean, 400 pounds of plastic is nice in a few months, but if we could do 4,000 pounds of plastic per month or 4,000 pounds of plastic per day, which is totally possible with this kind of method, then we'd be making a real difference.
I mean, I'd love to see you guys producing like 4,000 new portal sites for digesting 4,000 pounds each. You know what I'm saying? Like, I can see what you guys are doing is like a thing, you know, like as you build and grow and like notch out like this niche of what you're doing, you know, like keep in mind that, you know, like how could you help other people set these things up, you know, like in other places and get them going. I imagine there's other people working on similar things. Like you mentioned, you were working on the fertilizer aspect and then connected in this digesting plastic and, you know, like, yeah, there's other people working on these things. Like for example, this guy I saw, like people keep sending me this video about this guy that turned plastic into gasoline.
I've done that. Yeah.
You've done that?
Yeah.
Tell us about that, please.
So that's a process called pyrolysis. And actually we use a bit of pyrolysis in our methodology, but it's not really strictly speaking gasoline, although you can get it to become gasoline, but really so you can make styrene, which is very flammable. That's an aromatic, like oily fuel. You can make toluene, you can make all these aromatic compounds because it's all plastic is it's oil. It's just oil that's been polymerized, all frozen almost in a way. In the same way that ice is like frozen water, liquid water. This is just frozen oil.
Right.
So what we can do is we can break it back down into oil. You can put heat into it and it will come apart at a molecular level into organic compounds. Now, doing that can be dangerous. Like you end up oftentimes there can be fire and explosions.
Like melting plastic smells bad. So yeah, there's a lot of stuff coming out of that. Like
there's all kinds of stuff. So you have to do it. You can't just melt it, you know, over a stovetop. I mean, you can, but you really wouldn't want to. Pyrolysis is where you control the decomposition of it, where you instead of breaking it down in just the open air, you add something like nitrogen gas to make the atmosphere inert so it doesn't oxidize. You have to control the flow of gases. You control the temperature. You do it for a long time. But doing that, you know, you can get carcinogenic compounds can come out of it. You can release some really noxious fumes. So it's and the other thing is it takes more energy to turn plastic into oil than you would get from the oil. So there isn't really an energetic profit coming out of it. Now, if you can use solar power or other things to make it that way, then that's okay. But I don't think that's the solution. I think the solution is take the plastic and have microbes eat it as a food source. Just to get rid of it. Be done with it. Don't turn it into fuel. Don't try and burn it. Literally just break it apart at a molecular level into some soil and dirt and let it return to the earth.
Absolutely. Like, yeah. What do you guys think?
Yeah, we're totally with that. Yeah, we like that style. Yeah, what are you doing? We gotta get those microbials eating that stuff. Yeah, let's get on that. Come on. Okay, people, come on. Can't you get some funding and help these homies get this thing going? Let's go.
Yeah, the elves, they had to pop in on this episode for sure. I didn't know if they were going to or not, but hey, they do this thing. They're excited about these. You know, I love. We're totally with you on that. You know, like I've had. You know, like that's the real sauce. You knew what you're talking about. You've looked into it. You've tried this. You know, there's so many things like that where more energy goes into something than comes out of it. But you know, it looks good. It's off grid or something. You know. So yeah, that's like well thought. You know, it gives me, I don't know, here we're at Wake the Farm Up. We're Hope Day preppers, you know, where every day we're planning and doing the work, you know, for a hopeful future. And these are the kinds of things that give us little boosts along the way for sure.
I agree. I mean, I think plastic is a huge crisis. It's a huge problem. But I think there is more reason to hope today than at any point in the last century.
Yeah, we got excited on that. Wake the farm up.
Wake the farm up, man.
Today's the day. Today is the day to have hope, you know, and like these worms, these companions in nature, you know, and you know, fellow humans, hominoids and elves and dwarves and gnomes and trolls and all the things, whatever we want to identify as in this world, you know, we get to choose that and be whatever we want to be. And then 5 minutes later, we don't have no responsibility to be that anymore. We can be whatever we want. It's fascinating. And, you know, meanwhile, these interactions and flows with nature, this is a brilliant, brilliant story. Like, do you have anything else that you want to share with the audience here, you know, before we wrap this hour up? I know there's like so much more, so like we have way more time. I'm not even cutting into it. I'm just like share with us, brother Sam.
I would say that one thing is definitely be hopeful, but if you want to learn more, if you want to hear about what we're doing, you want to stay in touch with us, we have a website, we have an Amazon, we have Instagram, Facebook. You can look us up where we are WriggleBrew, WRIGGLEBREW, WriggleBrew. Seek us out. I'd be happy to answer any questions you have. I'm Sam at WriggleBrew.com. You can also hit us up at info at WriggleBrew.com. And just drop me a line. I'd love to chat. And if you have any ideas on how we can make this thing grow and solve some of these problems together, let me know.
Love that. That's so awesome.
And thanks for having me on Wake the Farm Up.
Absolutely. Hope to keep up with you. I mean, this is such a fresh thing, you know, like you guys are going to like grow up, you know, like some big tree, and I'll be like some little sprout that helps start a forest. If I can do anything along the way, let me know. And, you know, we'll be maintaining ground. I'll keep up with you, Sam. And, you know, like, absolutely, if Gabe ever wants to jump in the seat that's next to you and jump in the mic, we'll do another episode sometime, you know. I'd love to, you know, hear more as the plastic digester worms, you know, get into it. And maybe we could even pull a couple of those in at some point and see what they have to say somehow, you know, like, you know, we could probably come up, you know, find like a worm whisperer, or maybe like that's what you guys are getting deep into, you know.
Shut the farm up.
Maybe so. I mean, that's what we're trying to do. But thanks for having me on, brother. It's been an honor.
Awesome. Appreciate you. Elf out.
Sweet. Yeah, that went really well.
Would